4.10 is going to teach you that there's other type of trig graphs that can be graphed, and those are the reciprocal functions. So remember that. We have cosecant, which is the reciprocal of sine. We'll have secant, we'll have tangent, cotangent, and then we'll also have some inverse trig functions as well. But let's talk about just cosecant first. I want to just talk about sine values. So the values on your unit circle, when x is 0 degrees or radians, what is sine of 0? That should be a height of 0. Then we go up to pi over 2, which is 90 degrees. Y is 1. Then we go over to pi, which is 180. We're back to 0. And then 3 pi over 2 is going down to -1. And then 2 pi is all the way around. We're back to 0. So now cosecant is the reciprocal of sine. So what's the reciprocal of a 0? Well, 0 over, let's say, 1 becomes 1 over 0. That's undefined. So reciprocal of 0 is always undefined. Reciprocal 1, so having 1 over 1, flipping it is still 1. 0 is undefined. -1, flipping it is still -1, and then another undefined. So anywhere you see undefined, that means there's no point on the graph. So we're going to make those asymptotes. And what an asymptote is this imaginary line it'll never touch. So at x is 0, that's an asymptote. So make a dashed vertical line. At pi, asymptote, and at 2 pi, asymptote. Okay, and then we've got to point at 1, or sorry, pi over 2, 1, and 3 pi over 2, -1. And so what happens is if we had other values like pi over 4, think about sine of pi over 4 is square root of 2 over 2. Reciprocal of that is square root of 2. That's like 1 point something. It would be here. And so I'll just tell you that you're going to have like a parabola shape here. Same thing's going to happen here. And this goes on forever. So I could say here there would be an asymptote. And here there would be an asymptote. And then this would be here. And this would be up here. Now when I see a graph like this, and I'm not sure if it's cosecant or secant, what's kind of cool is if I were to graph the sine graph, so I know that it starts with a middle and then high, it goes like this. See how everywhere that it had a high it touched? And so really what I do is when I see these parabolas like this, I know it's one of the reciprocal functions. To figure out which one it is, I'm looking at, okay, the negative space of if I were to go up here and back down to here, this is sine. So let's do that same thing with secant. So let's talk about cosine at 0. That went right 1. At pi over 2, it's 0. At pi, it's -1 because we're going left 1. Down at 3 pi over 2, now x is 0 again, and all the way at 2 pi, it's back to 1. So now we're going to take the reciprocal of cosine. So reciprocal of 1 is 1. This is undefined. -1 is the reciprocal, undefined. 1 has reciprocal of 1. So let's plot 0, 1. At pi over 2, it's going to have an asymptote. At -1, let's see, pi, I don't know why I keep looking at that. You're looking at first column, second, or last column. Pi, -1. 3 pi over 2 is undefined. And 2 pi is 1. So really there's going to be an asymptote here. And it's going to go this way, and this way. And again, the reason I know they do this is because if I found other points, so like pi over 4 or my pi over 6 or pi over 3, those other values, those would create the points in here. It just creates this pattern over and over and over. And so what's cool, again, is if I were to connect these points, go like this. So I know that this is a reciprocal graph of cosine because I see where these would touch. Okay, going on to tangent. We have not graphed this at all yet. Tangent at 0 degrees. So think about slope here. So at 0, that's a horizontal line, that's 0. Pi over 2, that's undefined, because it's a vertical line. At pi, it's back to 0. 3 pi over 2, it's back to undefined. And at 2 pi, it's back to 0. So now we have asymptotes at pi over 2 and 3 pi over 2. Okay, so I'm going to go ahead and do my every 2 an asymptote so you can see this. If I have a point at 0, 0, and then this, it's kind of hard to see what's happening. No, I don't have a parabola, because actually, if I had, say, negative pi over 4, which would be halfway between here and here, that value, so negative pi over 4 would be down in quadrant 4 where tangent is negative 1. Positive pi over 4 is positive 1. So it creates a curve like this. And it does that everywhere. So it goes from down to up. Down to up. It's kind of mesmerizing, really. Isn't that cool? So that is the tangent graph. Okay, let's flip it over and try a few more. We're going to try cotangent of x. So I went ahead and filled out our tangent of x values just from going around the unit circle. Now we need the reciprocal of these. So 0, the reciprocal of 0 is undefined. Any undefined, the reciprocal is now 0. Because it's like having a fraction 0 over 1 and 1 over 0. This is undefined, this becomes 0. So they're just flip-flopped. Okay, so now I see that I have an asymptote. I'm actually going to have 3 of them that fit here. At 0, at pi, and at 2 pi. And then I'm going to have a point at pi over 2, 0, and 3 pi over 2, 0. And then let's pick again, let's say this is pi over 4. Tangent of pi over 4 is 1. And so reciprocal of that is still 1. This would be tangent of 3/4 of a pi. So that now would be a negative, because that's in quadrant 2, that would be negative 1. So now our curves are going to go like this, from down, I don't know that very good. Sorry. It's harder for me to draw like that. There we go. And then it has this pattern. So it's very similar to tangent, other than it starts from up and then goes down. Okay. And then the only other thing that we need to talk about is inverse functions. Inverse functions swap x and y. So if we go ahead and fill out our table for sine, just regular sine, we're going to start at actually negative pi over 2. So think of negative pi over 2 would actually be here, and sine would be the y value, which is negative 1. And then when it's at 0, sine is 0. Up at pi over 2, sine is 1. Now we're going to flip-flop. So now this is x, this is y. So at negative 1, I'm going to put a point at negative pi over 2. 0, 0 can't be swapped. And then I'm going to put a point at 1 up pi over 2. So it creates this little curved function right here. It stops, and the reason is because sine graph goes like this forever. And for something to have an inverse, it has to be a function, and it has to be a one-to-one function, meaning it has to pass the vertical line test and the horizontal. See, horizontally we'll have overlap of all these points, and so we want to pick an interval just from here to here, negative pi over 2 to pi over 2, which is what we did. But anyway, so when you see part of a graph stop like this, look and see, okay, here's a point at 1 pi over 2, switch it. When we have pi over 2, we get out 1. Well, pi over 2 is 1 when it's the sine function, so that helps me. And then the last one being cosine. Cosine goes at 0. We've got 1. At pi over 2, it's 0, and at pi, it's -1. So now we're going to flip-flop. So we're going to point at 1, 0, 0 pi over 2, and pi, well, sorry, -1 pi. So it goes like this. And so then that tells me, if I look at this graph and see, okay, which one is this? When I have, at this point, 1, 0 is actually when it's 0, it's 1 on the unit circle. So that goes with cosine. And again, we have to stop it because cosine starts high, middle, low, middle, high. We have to cut it off just from 0 to pi, or it starts to repeat itself.